Okay, so today we're going to do some more visualizations with different Python libraries. But before we begin, of course, go ahead and fire it up, right? So in your command line, okay, go ahead and type Jupyter Notebooks, right? Jupyter Notebook should come up actually. And when you click the notebook command, it will think a little bit and it will open it up in the browser, just like that, right? So the way how you know that this is running on your machine and not on the server is what? In the URL string it should say localhost 8888. Is that what you're seeing? Yay? 8888 is the port number where the program is running. Okay, so your computer is listening. So browser essentially is making requests to your computer, to your own computer, the hardware request. Okay, and the computer is listening on the port 8888. So the browser sends the request on the hardware port, and the hardware port basically is linked with the Python which is running on your machine. That's how the interaction happens between your browser and the Python program which runs. So everybody started Python, right? Jupyter Notebooks. Okay. So go ahead and in the menu New, yours I believe say Python 3, right? Yeah, mine still says Python 2. That's probably why I have to type an extra thing in order for the graph to show. Now, if I remember correctly, in the previous class what we did was we created really two simple plots, right? One of them was box plot, right? We created box and whiskers plot for the tips, right? We loaded the file which contained tips probably received by waiters and waitresses in the restaurant, right? Total bill, tips, who was the waiter, male or female, this kind of stuff, right? Okay, so today what I want to show you is a couple of different plots from a different data set. There is a fairly famous data set which is called Iris. So apparently it's about classification of flowers based on physical measurements of the flowers. So before we begin, let's actually go ahead and load the necessary libraries, right? So for now we're going to use the library called, which library did we use in the previous class to plot the Seaborn library, right? So how do we do that? We say import, right? Keyword import and then type Seaborn and let's give it an alias, right? We're going to say import Seaborn, and the standard way in Python community how to abbreviate that library is to call it SNS. There is apparently a story about that SNS. It stands for like first three letters of some fictitious character in some television series. So it was kind of pioneered by the guy who wrote the library in the first place, the creator of Seaborn library. Okay, so from following him, everybody when they import the Seaborn library, they just call it SNS as an alias. Okay, so let's go ahead and run it. Click on the run button. All right, and the star will tell you that it's still linking, right? It's still connecting to the library. And once the star turns into a number, that means that your library is up and running. Okay. All right. Let's go ahead and read the data set. Okay. So I'm going to call it data set Iris, just like the data file. Data file is also called Iris. Okay. So Seaborn library SNS we called it, right? It has the built-in function how to load or read the data sets from data files. Okay. So very straightforward. You say library SNS dot. That means that inside the library there is a function that we want to call right now. Okay. So inside the library Seaborn SNS there is a function load underscore data set. Okay. And inside the parentheses, you should send the function an argument, right? Which data set do we want to read? Remember we discussed that last class, the installation of Python and of the Seaborn library, it comes with certain standard data files that they just applied, right? They said, when you install the library, you're getting all the functions inside this library, the ability to plot, etc., but also some data. So data is already installed on your machines. So we can just go ahead and address the data set by the name. So quote unquote, and it's literally called iris. Okay? And as the result of that, it will create a new variable called iris, right? That's why I say iris equal. So I create a new variable iris, and it's going to be a data frame. If you remember, we discussed data frames in the previous class. Data frames are like spreadsheets, essentially, which sit in your memory of your computer, right? It has columns and rows, and each column can have its own data type. That's what's cool about that, okay? And let's go ahead and run this line. It says line 2, well, which means that the data set is loaded into the data frame iris, right? So let's go ahead and print it out, just for the heck of it, just to see. So go ahead and say iris, hit enter, and there it is, okay? So right there it says we have how many flowers? Not so many, right? 150 observations, 150 records, okay? And each flower had, how do you pronounce that? Sepal, and then there is petal, right? Yeah, so sepal has the length, it has the width, then there is a petal length and petal width, and species, right? And species, oh God, I don't even know what these things mean, okay? I'm not a biologist. So apparently this data set can be used, and it is actually used sometimes in class to explain classification tree. So all of you took the BUSN 231, right? No, not 231, 305, Introduction to Data Analytics. Alex is in this class right now. So we remember the classification trees, right? We classify each observation into one of the few classes. So this data set actually can be used for that purpose, okay? So depending on the physical measurements of the flower, on different parts of the flower length and width, right? We can classify which species, right, this flower belongs to. Okay. Anyhow, so what I'm going to do with this, the reason why I wanted to use this data set is we can actually plot different bivariate plots. Everything that we did in the previous class was univariate, right? One variable. We did the distribution of tips, right? Only one variable. So we did the box plot and also the violin plot, right? But it was one variable at a time, pretty much, right? So what I wanted to do is have a data set which has x and y both continuous, and therefore we can do the scatter plot, okay? So let's go ahead and do the scatter plot, regression, okay? That's how Seaborn library calls this data set. It's called the reg plot. So let's go ahead and create a new line for the new code. And in this code, here's what I'm going to do. I'm going to say SNS, Seaborn library, right? Dot, so I'm calling a function for the Seaborn library, reg plot. Oh, even before we do that, remember how, like for example, I'm learning about new function, right? And I don't know how to use this function. What do I do in order to get instructions? I can call help, right? So how about that? I'm going to say help, and inside parentheses, I'm going to say in the library SNS, there is a function reg plot, regression plot. Let's see the help. And when I run the code, it gives me the description of this function, right? It says, well, for the regression plot, that's essentially a scatter plot, okay? Scatter plot is bivariate, right? You have x horizontally and y vertically. So you have to supply x and y. You can optionally provide the data. Well, I mean, data you have to say. Which data are we using, right? But remember, we discussed two different ways how we can do it. Well, we'll do it again today, okay? And then the whole bunch of other parameters. So let me be simplistic. I'm just going to supply x and supply y, and that's it. All right, so I'm going to go ahead and scroll down, add additional line. All right, and I'm going to say, now, Seaborn library SNS dot reg plot. Okay, and I know that first thing that I have to supply, the function is x, right? So let's take a look. How about this? I'm going to plot sepal length versus sepal width. So sepal is, which part of the flower is the sepal? Isn't it like a green kind of leaf which surrounds the flower? Kind of a bunch of, I don't know, I'm not a biologist. So I just looked it up on Wikipedia, and apparently petal is what? It's like the colorful part of the flower, right? That's what makes it so pretty. And the bunch of green leaves that surround this part of the flower is called sepal. Okay, so, all right, so let's see if there is a relationship between the sepal length and the sepal width. So that's what I'm going to do. I'm going to say x equals quote unquote sepal underscore length, okay? And after that, I'm going to say y variable vertically is going to be same thing, quote unquote, sepal underscore width, okay? Now another argument is, I mean, if I run it right now, what do you think is going to happen? It's going to throw an error. Why? Exactly. I didn't say where from this data is coming, right? So I'm going to say data equals, and I'm going to point it to the data frame which I just created when I read the file, right? What was the name of this data set? Iris, right? So that's one way to do it. Okay, I believe if you run yours code, it will actually create you a plot, right? Okay, mine didn't because I'm running Python 2. So let me add a couple of things, well, here probably, right? I'm going to say import, you don't have to do it because you got it already, right? Import matplot lib.pyplot as plt. And after I import, whoopsie, what did I do? Oh, okay. I put an extra comma in there. And after that, I'm going to say, well, library plt, show me the plot. Show me the plot. And now I get the plot. Ooh, did you get the regression as well? The line in your plot? Okay. So, essentially, what does that tell you, this plot? It's almost, it's pretty crappy, really, right? As far as the fitting the line is concerned, because if you imagine that there is no line, right, you can't really pinpoint any kind of relationship, almost, right? So there are no obvious lines, almost obvious patterns or anything quite like that that are happening, right now. Okay. So that's why probably your regression is almost horizontal, right? The line has almost no slope. It's actually negative, right? So it means that as sepal gets longer, what happens with the width? It kind of starts to narrow down, right, a little bit, which is weird. You would expect straight correlation, right? This part of the flower gets longer. It's also getting wider. That's what kind of common sense dictates, but apparently not happening, right? So if I want to show this, so it shows the straight line fit by default, right? But what if I want just bunch of points, just a scatter plot, no line, okay? Can I do something about that? Well, let's look at the help for the function, right? So if you look at how the function is being used, you have to specify x, y, and there should be, yeah, right there. You see that one? One of the arguments that you send to the function is called fit_reg equals true, right? Let's scroll it, parameters, right? And let's find what exactly does that mean. Fit_reg, boolean, optional. If true, estimate and plot a regression model relating the x and y variables. So we didn't specify anything, so it said by definition it's going to be true, right? So I'm going to show the linear regression. So what if I don't want to show the line, how it fits my data? Well, let's try that, right? So after I specify, let's rerun this whole thing again. After I specify that the data should be iris, I'm going to say reg fit, or is it fit reg? Remember how is it spelled? Fit reg? Yeah, fit reg. Fit_reg. equals false, right? False. And this time around, actually, let's see if it works, okay? Here's what I'm going to do. Just to emphasize that this is case sensitive, okay? I'm going to spell the word false with a lowercase f. All right? And because it's not highlighted, you can see that if I type the word import, it highlights green, right? It's because it recognizes the word, right? False and true should be also recognizable. You see what I did? I typed the false with lowercase f, and it's not highlighted. That means that it doesn't understand what the hell that means, right? And if I run it, nothing happens, right? It says name false is not defined. So Python, I believe I told you that before, right? Python is case sensitive. So lowercase false and uppercase false, they're not the same. So I have to go back and correct, right? So uppercase false, and now it's highlighted green, right? Now it says, yep, I know what you mean. And now if I run it, it's the same plot but no line, right? How cool is that? Yay. Okay, any questions? We good? Melanie? Yay? Will? Carlos? We're good. Okay, well, let me show you something fancy, okay? Something really funky. So, go ahead and, in the new line, let's do sort of the same plot, but which looks a little bit differently, okay? It's kind of like a density plot. So it shows you the regions where the points are mostly concentrated. It almost looks like, if you ever saw the geographical maps of the heights, right? So there is like ISO height line, which connects the points with the same height, and then the next one. So it kind of shows you the landscape, so to speak, right, of the land. So let's do the same plot, okay? So it's going to show the same exact information, but slightly differently, okay? And this is called joint plot, okay? So, and guess what? It's coming from the same library, so we're going to have to type SNS, right? Seaborn library. From this Seaborn library, we're calling function joint plot, okay? And joint plot, we're going to specify, let's do exactly the same thing, right? I'm going to say joint plot, it needs an X, it needs a Y, and it needs the data, right? So, oh, and this time, here's what I'm going to do. Just to show you that there is more than one way to specify the data source, I'm going to say X equals to data source is iris, but inside this iris contains many variables, right? It has many columns. So inside this data source iris, I'm going to take a column called sepal length. So in the square brackets, after the name of the data set iris, in quotations, because it's the name of the column, I'm going to say data set iris, square brackets, the name of the column is sepal underscore length, okay? So it's kind of two in one, right? In one statement, I am specifying which data to use and which column inside of this data to use as my X variable. And I'm going to do the same thing with Y, right? I'm going to say comma, Y equals, data set is iris, square brackets, and inside the square brackets, the name of the field. That is going to be sepal underscore width, okay? So this way, I don't need to specify data because it's there already, right? Saying data set is going to be iris, and that's the column from the data set. Well, you know what? Just for the heck of it, let's run this code as is and see what happens. It's probably going to give us the same exact plot. That's what I'm guessing. So I'm going to say plot show. You don't have to do it because it shows for you automatically. Yeah, it's almost the same, right? Pictures are kind of identical. Well, what did you expect? It's the same data, right? But what does it do also? What's the difference between just regression plot and these joint plot? It kind of shows you more information, right? It shows you what's this thing on the top and what's this thing on the right cut. Histograms, right? So it tells you horizontally, X variable is your sepal length, okay? So therefore, on the top, we're going to show the distribution of sepal length in these 150 flowers which constitute the data set, right? And the same thing happens vertical, right? So vertical variable is the width. Here is the distribution of different widths, right? And in the main area of the plot, here is our scatter plot, okay? Now, let's go ahead and call for help, okay? Remember how to do that? How to call help on something that you don't know exactly what it can do for you. So you're going to say help, right? And we specify the name of the function. So we're going to call SNS library Seaborn, right? And we're going to say this is the function joint plot. And when you hit run button, it gives you the function, right? So look at the third parameter, which it can take. We also can specify what kind of plot it's going to be. And it can be a scatter plot. REG probably stands for regular, whatever that means, right? Resid probably stands for residuals, right? Because it fitted the straight line, so therefore we can calculate the residuals. Or there is a mysterious option KDE or hex, right? Well, let's explore different options. So right now, what I'm going to do is after the my x and y, I'm going to put a comma and specify that variable. And the variable, the parameter is called kind, right? What kind of the plot is that? So kind, I'm going to say kind equals, well, let's start with scatter, right? Because it's one of the options. It says scatter with a lowercase s, by the way, right? So scatter is one of the options. And I rerun the plot, and it's the same thing, right? So now let's change it and use KDE. So when you're saying what kind of plot is that going to be, let's go ahead and see what KDE gives us. So specify KDE, the kind of the plot, and when you hit enter, it gives you this. It's kind of a cute map, right? Looks pretty cool. Remember when I told you that it's kind of going to connect the points of the, probably what it shows you is the density, right? The regions which contain approximately same density of points, right? And when the points become more and more rare, not so dense, then it calculates and shows you another boundary and another boundary. So it's kind of a heat map in a sense, right? It shows you where the concentration of the points is the highest. So you can see that we have kind of two spots, right? Relatively dense area right here, and quite a bit dense area right here. Okay? So that's basically how the distribution looks like. Is that cool or what? Well, let's explore another option, right? Let's see what happens if we say hex. H-E-X. That was another type or kind of the joint plot that can be produced, right? So when I run it, it pretty much tells you the same information, right? It's just different representations of the same data, essentially, okay? But it shows now things a little bit different, right? Instead of calculating the regions with like uniform density and coloring them the same, now it says, well, let's break it down into the hexagonal areas, right? And depending on how many points fall into each area, let's color it different, right? More dark or more light, etc., etc. So essentially, you can see the same thing, right? Two different regions. This is fairly dense, and this is a lot dense. Okay. All right, just showing you some of the options. Okay, what this thing can do. All right, let me show you another library. Okay. This library is pretty cool because it allows you to make these graphs are not interactive, right? These charts, they're just for display purposes. Okay. All of you took BUSN 305, and in BUSN 305, we're using Tableau, and Tableau gives you interaction, right? That's what's cool about it, okay? You can interact with the graph. You can click on one of them, and it will update other graphs, etc., right? That's really cool. These are static graphs, right? You can change them. You can zoom in, you can zoom out, you can, move things around, nothing, okay? There is another library which is fairly popular. It's called Bokeh, B-O-K-E-H. Okay, and what's cool about this library is it creates for you interactive graphs with which you can actually interact. Okay, so let's add another line. Any questions? Are we moving too slow, too fast? Just right. Just right? Everybody keeps up, right? Will? Yay? Travis? Yay? Okay, cool. So let's add another line, okay? And let's link the library. I believe it should be installed on your machines. So it all requires, of course, installation, right? And it's very easy, actually. I'm planning over the spring break, maybe recording a video, how to install all that on your machine, right? Where to go, how do you link the libraries. Python makes it very easy. There is something, a small program which is supplied with Python, which is called PIP, PIP. It's called pip install. So you just go, to the command prompt and you type pip install and the library name, pip install bokeh, and then 5 minutes later or 2 minutes later you have yourself another graphical library on your machine. That's the real power of Python. We discussed it, right? There were tons, literally thousands and thousands of libraries written for Python, and the same applies to R. Okay? These packages, they're basically maintained by community of programmers. So people contribute their time and talent. They create these libraries that will allow you to do all kinds of data visualization, data modeling. You can create regression analysis. You can create classification tree with these libraries. So it's very powerful. So really, what it boils down to is, do you know most popular packages, or can you find your way, right? So for example, let's say I want to do certain exotic analysis, some model which is not very widely used. All it takes really is researching other packages, other libraries programmed for Python or for R that do exactly that analysis. Finding these libraries, importing them, and then just using these libraries, okay? So literally, like I said, thousands of them. So it's a very diverse, diversified tool. Okay, so let's go ahead and import another library. So we're going to actually do it a little bit differently, okay? Instead of importing the entire library bokeh, here's what we're going to do. From the library bokeh, B-O-K-E-H, okay, and moreover, not just from the library, but from a kind of sub-library called plotting, bokeh.plotting, okay, import few of them, okay. Let's import a module called figure. Let's import module called outFile, out_file. OutFile will create an output, HTML output for us. Okay, you will see exactly what I mean. Okay, and also let's import the module called show. That's for showing. Okay, so when you create the plot, it becomes an object in the memory, right? But you have to display it. And that's what show module does. Okay, so from bokeh.plotting, import module figure, outFile, and show. So let's go ahead and run it. Click on the run button, and I screwed up something, right? Cannot import. Why can't you import figure or outFile? Do you have the same? Cannot do the outFile? Wow, that sucks. Why not? OutFile. Okay, at least we have show, right? All right, let's see if we can do without outFile. That's weird. It was just working for me. Figure outFile. Did I misspell something? Out_file and show. All right. So let's erase the outFile for now. OutFile. And let's just do the figure and show. All right, so let's try that. I'm going to add a new line. Here's what I'm going to do, okay? I'm going to use the same data set. Iris length and the iris width, okay, or cpal length and cpal width. Okay, and let's do this. First of all, I'm going to say object P is going to be a figure. Okay, so it's going to be like a plot, figure in terms of plot, right? Let's specify the plot height and the plot width. So it takes. So in other words, I'm defining how wide and how high my picture is going to be. So quite literally, plot underscore height equals, and because it's a number, I don't provide the quotations, so it's 400. Let's just try, right? 400. And the plot underscore width equals also 400. So it does nothing really. It says, well, P is going to be a picture with these dimensions. That's it. Okay, so I didn't do anything really right now. Okay, so let's run it, and it does run, right? No, nothing to display right now. So it's just an object in the memory. That's it. So now let's add another line, and here I'm going to actually create a scatterplot. Okay, so I'm going to say that object P make the scatterplot out of circles. So P dot circle, okay, and inside of this circle function, I'm going to specify exactly same things as I did before. I'm going to say x is equal to dataset iris, square brackets, and the column name is going to be quote unquote cpal length. So I'm going to do exactly the same thing, right? cpal underscore length. Okay. All right. Then comma y equals iris dataset square brackets, and inside the square brackets I'm going to say quote unquote cpal underscore width, right? Okay, and that pretty much is how I construct my plot, right? And after that I need to show the plot. So I'm going to say show plot P. Okay, so call the function show, and inside the brackets, inside parentheses, I'm sorry, just say this P object which we just created, show it. Okay, and let's see if it runs. So what happens when you run it? In a new window, right? That's something that you should see, right? So look what happened. It actually created a file. If you look, so you should see something like this, right? What actually it did is in the browser, right? In the URL string, you can see that it points to the file, right? In my case, it's located in the folder C, subfolder users, my ID, app data, local temp, blah, blah, blah. It says tmpsci2ur.html. Okay? What's .html? .html is what type of file? Web page, right? It's a web page. So, you see what's cool about that? The output is not in the browser, just like we used to, right? So we used to the fact that when you run something in Python in Jupyter Notebook, it actually shows up in the browser right next to your code, right? So it's kind of embedded in the same session that you're running right now, okay? So output is kind of inside of your browser, inside of the session that you're running. So here, the output actually is an HTML file. So you can find this file, right? Or you can go ahead and save it as whatever it is, .html, and later attach it to email, send it to somebody else. They double click on the attachment, it shows up in their browser, just like this one, right? So you're sending a web page. And what's cool about this blockcache library is it's interactive, okay? So for example, I can pan around. I can click and literally drag things, okay, in the view. Something that I couldn't do before, right? That's what's cool about this library. I can zoom in, so here is the zoom function, okay? I can select area using the mouse, like rectangular area, and it will zoom in. If I reset, then the next option is wheel zoom. So if you have wheel on your mouse, right, you can just scroll it up and down, and it will zoom in and zoom out. Okay, I can save, like I said, right? So when you click save, apparently the only thing that I can do with this file right now is save it. And it saves it as a picture, right? That's weird. It's kind of weird that it doesn't offer me the option to save it as the HTML, right? But what happens if I click? Yeah, if I click in the area, right click and say save page as, then it offers me to save it as the complete web page, right? So I can save it in any location on my computer, and if I want to send it to Melanie, for example, I'll just type an email, attach this HTML file, she will get the file, and she will double click on that, opens in the browser, still same interactivity is preserved, right? That's what's cool about it. Okay? How do you like it? Super cool, right? So I just wanted to show you this specific graphical library. Okay? All right. Well, let's experiment a little bit. Let's close this thing, right? So what if instead of circles, okay, let's try this. I specified the height of my plots, right? So when I said figure, create the object P, which is going to be a plot, and it's going to be a picture, a figure with certain height and certain width. What if, let's experiment, let's play around, right? What if instead of 400, I go ahead and put it equal to the 800, okay? And moreover, instead of circles, my dots on the scatterplot were really like teeny tiny circles, right? So how about I'm going to make them into squares? That actually can be done. So here I used function circle. I said the chart, my plot P dot circle, right? Use the function circle. So here now instead of circle, I'm going to make it square. Use the function square, so therefore my dots on the scatterplot will become like little squares, okay? So let's go ahead and run it. Well, first rerun this, the first line, which says P equals to figure, because we reset the size, right? Instead of 400, now we're saying let's make it 800. So rerun this line, and now rerun that line right here, okay? Go ahead and select it, and it will show up in a new browser. Mine shows up in Firefox. Yours does the same thing? Which browser does it open? Which one? Oh, it's just a new tab in the Chrome? Wow, I'm wondering why the hell does it do it for me? So there you go. Do you see that they're little squares, and not the circles? Yeah. And the plot itself is much bigger, right? So maybe, hold on, let me go back, and let's do this. Let's scale it down a little bit. So instead of 800, let's make it 600. Each dimension, 600. And now I'm going to add a new parameter, okay? So how about I'm going to change the size of my squares. So I'm going to say comma, size, argument, size equals 5. Let's see what that does, okay? So when I say that it's got to be a plot with squares, where it plots x versus y, I'm going to specify the size of my squares. Size equals 5, right? So I made the plot a little bit smaller, 6 by 600, okay? And probably squares are going to get larger, right? That's what I'm guessing. So I'm going to run both lines. So this line, where I'm resizing the size of my figure, and I'm going to rerun that part. Okay, so it opens up a new browser for me. Yeah. Is it different really, the sizes? No, I don't see the difference. All right, let's go back and resize it to, for example, 10. What will happen? So yeah, well now they are different, right? Now they're twice as large. So, and I can pan around, right? I can zoom in. So it's pretty cool. Okay. Make sense? Any questions, concerns, complaints, sarcastic comments? After the spring break, probably I'm going to come up with a nice data set for you to visualize using the Python, okay? Attaching different libraries. And I'm going to ask you probably to use some of the functions that we used in class and some of the functions which we didn't use in class. I'm going to ask you to be proactive, right? And investigate, okay? So you have to do your own research, find out how the function works, maybe some examples of how the function works, and pretty much come up with a visualization, okay? So I can't show you, of course, all the libraries and all the options, right? Every single plot. So therefore, you have to learn how to find this information yourself. Okay? All right. So this is it for today. And I'm going to stop the recording right here.